Hello and welcome back. Today we'll discuss some important details when dealing with convolutional neural networks, in particular the filter sizes. So how do we determine the output sizes when we chain together convolutional layers? As a brief reminder, how do convolutional neural networks work? In principle, we apply a filter, the so-called kernel, to the image and slide the filter across the image, as we can see here. There are two important aspects: stride and padding. Stride is essentially our step size. So when we have a filter of a defined size, say 3 by 3 in our example here, this maps it to a particular point in the next layer, so we can see the light shaded area in the second image raster on the right. And then we need to move this along. As we can see, when we do this and we stay within the borders of the image, we sort of lose a bit of flexibility of the corner pixels. And this is where padding comes in. So to avoid that the filter makes the image smaller after we apply it, we can pad the image so that we, for example, add zeros around it, and then we can extend the filter outside the original image size. So how do we then determine the output size? Typically in a convolutional neural network, we chain multiple layers. So for example, we have our input image and the first CNN layer and so on. And there may be some pooling layers and some more pooling layers and more convolutional neural network layers and so on. So that in the end, we have a pooling layer and then a final linear dense layer, for example, for image classification. So each layer of the convolutional neural network has a number of connections, and we need to determine how to chain these together. So let's start with a simple example, the MNIST data. That is a typical example for learning convolutional neural networks. This consists of a number of handwritten images, and we can see here that we have the number 7, and it's a pixel size of 28 by 28 pixels. And then if we apply a filter, so we would put this image into a convolutional neural network, apply a convolutional neural network layer, slide the filter across, and at the end, if we do this a couple of times, we have our dense layer classifying if this is the image, showing a number of between 0 and 9. So the output size depends, of course, on the input size. In our case here, we have 28 by 28 pixels. This is the dimension of the input image that we're dealing with. And of course, the filter size, if we have a large filter, it makes a difference as if we have a small filter. And of course, the number of filters that we use in a convolutional neural network layer. The stride, our step size, and whether or not we use padding. In our example here, we only have one color image because it's a black and white, not even a grayscale image. We see it as a grayscale image here because of the anti-aliasing, but it's really just a black and white image. So we only have one color channel. If we had a colorful image, then we would have 3 colorful color channels each for one of the colors RGB. And this would be represented by stacking essentially the image in 3 different layers, like in Z direction indicated here. So how do we do this? So the input size is now 28 by 28 by 1. So 28 by 28 was the size, the dimensions of the image. We have one color image. The filter size is typically 3 by 3, and then the number of filters depends on what we want to choose, but for computational reasons it should be chosen as a power of 2. We also need to choose stride and padding, right? So stride is move n pixels at the time. For example, typically we use stride equal 1, but you could also have stride equal 2 if you like, and padding defines the behavior at the picture edges. Putting all of that together, this is then the formula for the output size. It's the floor, that means the nearest integer downwards. So 2.1 would be, the floor would be 2. So the floor of the fraction of input width corresponding for the height, right? So we'd have both separately. Then the filter minus the filter size plus 2 times the padding divided by stride plus 1, and as I said, the floor of that number. And this is how we then determine the output size on the convolutional neural network layer. So for example, for our MNIST data, we have 28 by 28 with one color channel with a 3 by 3 kernel, stride 1, 0 padding, you would have 26. Also, we need to remember that we have pooling layers. Remember that the key idea of pooling layers is that we want to retain the most relevant summary features. For example, max pool, like if we have a pooling layer like this, we would divide the area on which the pooling layer is applied to, and then into these colorful squares, and for each square we would retain the maximum value and move on to the next layer with that. And there's a similar formula for the output size of the pooling layer. Also the floor operator, here we use the input width minus the filter size divided by stride plus 1.